Hi everyone, I'm happy to release and share another one of my designs with you. This is the transistor tester from the previous video completed, and it works extremely well, and I know I'm going to be using this a lot, especially for sorting surface mount transistors. Lots of times you pull a bunch of them off the tape, and sometimes you mix up NPN and PNP surface mount parts, and they just have a code on them. They're very hard to identify, so I can slide them over to the little pads on here with my finger and identify them. So it's going to be really, really handy for that. Now, underneath this video, there are 3 attachments. As you can see right here, there's a component layout map. Your version will have all the components listed on the actual component layout map. We'll take a look at this here in a moment. There is a schematic that has been modified. I managed to trim out 2 other components on here to even make it simpler yet. So that is very beneficial. And then there's the sized PCB layout. So if you use the toner transfer method, it's already mirrored. Just print it off, do the toner transfer method, and you'll end up with a circuit board just like this in minutes. So from printing this thing off to putting the transfer onto one of these circuit boards takes me about 10 minutes. That's about how long it takes, running it through the laminator, and then of course just etching it after that, and that's it. And then, of course, you have population time on top of that as well. But very, very fast to prototype these little boards. Now, the nice thing about this project is this pleases 2 different crowds. We have the surface mount crowd, and we have the through-hole crowd. This is through-hole components surface mounted. So it's both all in one. And the reason that I did that in this project is because on the top here is this little SOT23 pad area. So again, if I'm sorting any SOT23 transistor, I can just slide it over with my finger, push down on the pads, and it will identify it. It's right on the top side of the board. I didn't want to make a double-sided board because, again, that just adds complexity to this. So I try to keep everything as simple as possible in a single-sided build right here. It worked out really, really well. These are just single inline pin sockets here. You can find them anywhere. They're gold plated. You can find all sorts of different types, so nothing special here. You buy them usually in strips and you just clip them. So you can clip them down to 3 or 4 or however long you want the single inline strip to be. So I trimmed out 2 3s. I put a space in between. This actually would be one extra, I guess you could call it, pad in between there. So just to separate these 2 sockets. So this is the American and European transistor socket, and this one here is the Japanese socket. So 2SA, 2SB, 2SC, 2SD will go in this one. And, 2N, whatever, BC, and all those different types of transistors will go into this one here. Very, very simple build. I left some extra pads over here. I'll zoom into this here in just a moment. We'll take a closer look at these. I left some extra pads here. So if you wanted to make another jig for, say, TO220 transistors or TO3, those big metal ones, something like that, you can just run some leads off, or even alligator clips if you like. On the corners here, you'll see a bunch of pads. You can drill those to whatever size you want to mount this in a project box if you like. If you wanted to put this inside of a project box and just had the LEDs poke through, like the through-hole version right here, you can use this to do that, and I'll tell you how to do that here in just a moment. You can just use this actual printed circuit board layout, the PCB layout itself, to do that. It works out very well, very easy that way. Not much to talk about with this thing. It just works incredibly well. So you can see here I have through-hole components, through-hole LEDs right here that were seen in the last video, and you can see that I have surface mount ones here. These 2 circuit boards are identical to each other. There's nothing different about the boards. It's just some components. The nice thing about this board here is that these surface mount components will solder directly to the tops of those through-hole pads. So nothing needs to be changed. You can just take, if you want these red and blue LEDs right here, all you do is you just put them on top of the pad and solder them on, just like that. And then, of course, this is oscillating at a much faster rate because of this capacitor here, as explained in the previous video. So this is the slower version because of the LEDs. So, and that, again, that was explained in the previous video as well. So on the actual component layout map that you will find below this, the components for the fast and the slow version are listed there. And on the actual schematic, the part numbers for these LEDs and these LEDs are there. Everything else is pretty much self-explanatory. The part number for the IC is the part number for the IC. These are just little, single inline pin sockets. That's all they are. You type single inline pin socket and, they're about as common as dirt, really. So you can find them from whatever manufacturer that you want to favor. And everything is just readily available. No programmable parts, nothing like this. Just all off the shelf, fun to build, easiness right here. I tried to make this as versatile, again, for the through hole and the surface mount people as possible. Now, I'm going to tell you, a lot of the projects that are built here will be, some of them will be simple, some of them will be complex, but I am continually getting emails from semiconductor manufacturers telling me about product end-of-life notices for through-hole parts. So what I'm telling you is that a lot of the through-hole parts are starting to go away, and a lot of this stuff is going to be surplus market stuff. All the time, I'm end-of-life TO92, so I'm not going to be getting a certain transistor in a TO92 package anymore, or end-of-life in a DIP package, whatever. I'm continually getting these things. So it is kind of pushing us the way of surface mount, but I will try to build as many through-hole components, through-hole builds as I can. And of course, some of the larger builds will have to be surface mount just because of the, the component count and, the complexity of the build. Again, if I was to build this whole thing surface mount, it would be this little corner right here. Only LEDs would be there, and the biggest portion of this would be the the test area, and that could even be on a separate board if I wanted to build a separate little jig. So you would maybe screw a circuit board down to the top of a project box, and it had all the different sockets on it for testing different transistors. This whole thing itself would just be this corner if it was surface mount. So you can really see how much bigger everything is when things are through hole, right? So of course I could condense this just a little bit, but then we're building things through hole here, so we want to keep things easy to put on there, right? So that's that. So what I'm going to do is I'll move some of the stuff around here, and I'll talk about these 3 pieces of paper and give you some of the highlights of the build. This worked out extremely well, and I know I'm going to be using these things a lot. Again, just for surface mount alone, and I have so many TO92 package transistors that I need to go through and just test and verify, and this is going to be wonderful. I'm really going to enjoy this. So I'll get this out of the way, and I'll start talking about the paperwork. Here's the component layout map that is just below this video as an attachment. All the components are listed on your version. Uses just simple quarter watt resistors, and we'll take a closer look at the circuit board here in just a moment so you can get a good idea of the components you need. Just really off the shelf stuff. Very standard components. They've been around forever. This little surface mount pad here, I've made the pads a little bit bigger so you can take a surface mount transistor and just slide it over with your finger and push down on it. Doesn't matter if you run the transistor over the pads all at the same time. It's not going to hurt the transistor. So you just bring the transistor over and press down on it, and if it's an NPN or PNP transistor, you will know what it is. So that's very beneficial. So the collector and the emitter are reversible on this just because of the way this is set up. So I just put EBC to make things easier to figure out. So this is the emitter-based collector that runs off to alligator clips or a test jig. You'll see E, B, and C listed on these transistors up here. That is not interchangeable. Those are actual components. So this area down here is just the test jig area. Everything above this is all listed and needs to be installed the correct way. You'll notice index marks on the component map that you have. Use the index mark to indicate which way to install the LEDs on here. I'll talk a little bit more about that in just a few moments when we take a look at the circuit board. Very simple layout, it's just incredibly easy, really just a handful of off-the-shelf parts, and this thing is ready to go. Nice thing about this is if you forget to unhook the battery, so say you've got your 9-volt battery attached to this thing, the circuit board, when nothing is in the jig, all right, so when the LEDs aren't flashing, if this is attached to a 9-volt battery, this pulls in the low microamps. It pulls very, very low current just standalone. So if you were to forget and leave your battery hooked up or leave the switch on, the battery would last an extremely long time. Just if you forgot. Now you can add an on light or a power light to this if you want. I just have the pads that run off to the board here. You can put a switch in and put it in a project box. This very, I guess you could say there's endless ideas that you could add to this. So When I say I reduced some components, I reduced a bunch of resistors over here, and I'm just using jumpers here. Now, there's a balance that I'm playing with here. If I put the resistors in here, it's much more sensitive to faults in the component. So like leakage and things like that, it would much easier, detect it a little bit easier. With the jumpers in here, it will differentiate between different types of transistors much easier. You'll get quite a color difference, or I shouldn't say color difference, but brightness difference between LEDs. So if you have a 2N transistor plugged into this socket, you'll very easily be able to tell because the LEDs won't be lit evenly. And then, or you'll only get 2 lit, or maybe 2 on this side lit, something like that. Whereas if they're in the correct socket, and of course the transistor facing you in the correct socket, if it's NPN or PNP, the lighting is very similar. You'll see differences in the lighting between the two sides here if something is not quite right, and you'll notice that. That's something that you'll get used to as you play with this and start to experiment with this. Again, this doesn't spell out emitter, base, collector, and it doesn't do all that kind of stuff. This circuit here does require some brain power, but this is a very, it's such a simple circuit to use, and really, it's, just a handful of parts. It really worked out quite well. So once you get used to it, you'll find this to be very versatile. I'm already used to it, and I've sorted many transistors on one of the jigs already, so it's a very, very handy little device to have. So this here is the component layout map. And then, as shown in the other video, this is the other schematic that was in the previous video. You will have another schematic that is very close to this, but there's a few modifications to it. And that is just below this video. And you can correspond the modifications to the actual component layout map. You'll see what they are. All right, so there's that. And then there's a printed circuit board layout, all mirrored and ready to go. So this is perfectly sized. If your printer and your PDF scaling is correct, which most of the time it should be unless you've played with your printer scaling. So as long as it's set to basically no scaling or 100%, you will get this size. Now I get a question all the time, Paul, how can I verify this before I make one of these things? Very easy. Take a dip IC of some sort, or if you have some single inline pin, anything that looks like this, I'll just zoom on in. So in order to verify size, if you have something like this, I use these for my little jigs for surface mount. I put little circuit boards and then surface mount things on. Let's see if I have one right here I can show you. I have one that isn't put on one yet, but yeah, what I do is I can put like a surface mount LED on the top there, and then what I'll do is you can clip these because they have these little rows right here. You clip it right there and then just solder this onto the bottom. And then I can plug this into my breadboard to do experimentation. I call these breakout boards, and I have a huge sheet of these things. I make them in all sorts of different shapes and sizes, so I can take surface mount stuff and break them out. So you can let me know if you want me to share some of my breakout board designs with you. You just cut them off with basically like a shear. And, you can cut these off. Like these here are big enough that I used in a bandsaw and cut these, and then I ground them straight. But these kind of things, here's one right here. So I just cut these off with a shear, right? And then, you can put a surface mount component into your breadboard. Anyways, different topic. Okay, so these are single inline pin. This is a row, okay? So what you do is you can just take this and put it right above, and you can see the little holes in the center of the pads. It's perfectly in line, okay? Not down here, ignore this because this is another component. But on the IC, if you wanted to check the scaling, you can just have one of these things sitting handy like this and do that. And you can see it's perfectly in the center of every pad. And then if you want to see if the spacing this way is okay, just take it here like so. And you're going to be dealing with 4 pins, and you can see this pin is right in the center, and that pin's right in the center. It's sized correctly. So you just have one of these things around, print this thing off, and just put it on top, and you know whether things are fine. And it works the same with the transistors. These are like, the same thing. This would be like a single inline pin pad layout right here. You can see the little ones right there, right? So 3, right? If you have 1 or 2 of these that are correct, they're going to be okay. The whole thing is going to be okay. So at any rate, so that's what it is. This is mirrored and ready to print and already sized. So again, I'll just back this out here a little bit. So again, as long as your printer scaling is correct, you should be able to print this thing off. And then since this is mirrored already, you put that right onto the copper and then do your toner transfer method, and it will come out looking like a circuit board, right? Because if you take this and put this onto copper, right, you're going to have that on the other side. I don't know if you can see it through there. You can see it looks like the circuit board, right? Because it's mirrored. So, I don't know if you can see that maybe. Get some light under there. Yeah, anyways, you get the idea. So it's all there. These three attachments will be just below this video here. In a moment here, we'll take a look at some circuit boards. Here's a closer look at the top side of the circuit board, and as you can see, they're just through-hole components soldered to the top. Now, it's all drilled, so all the components actually, the legs protrude through the bottom, and then once they're soldered, I just trim the excess off on the bottom side here. And that makes for a very strong build because the actual legs of the component go right through the board. So it's really hard to take any pads off like that. So very robust build like this. And oh, as you can see here, it's very easy to get the soldering iron tip under there as well. Lots of space, right? And even space under the resistors to do the soldering. Now, this is one of my favorite tips for my Hako iron, however you want to say that. So this here is a Play-Doh tip, and this is the one that I use for through-hole and surface mount work. I use this for 0402, the really, really small stuff, the little parts that are the size of a pepper, basically a little grain of pepper, a grain of salt. I use this for that as well. So this is the Play-Doh HS4791. Really nice tip to have, and it's great for any type of circuit board use. So if you have like a Hako 936, or you have the FX888D like I have a bunch of them, this will work in either one of those. And as long as you keep the tip tinned, and you don't bring the tip over temperature or anything like that, and you don't use this to pry anything, it gets very tempting. I got to tell you, when you have a hook tip, if you want to pull a component out, you want to use this and lift it up, you got to resist that temptation because you don't want to take the plating off the tip. You don't want to scratch this or anything. You'll get a lot of life out of these things. I get years, no kidding, out of these tips. And that's just through taking care of the tip properly. So I've talked about tip care before in my other videos. Basically, the thing is that if this is going to sit in the holder for a long period of time, you always want some waste solder on the tip itself. So always add some solder, so like a ball of solder sits on it until you're ready to use it. Then clean it off, use your tip, and before you put it back in the holder again, add some more waste solder to it. So to give you an example, I have my other one here that's been off for quite a while, and that's what it looks like. You can see that waste solder is just sitting on there. So before I shut my iron off, I clean the tip, add a bunch of solder, and then immediately shut it off every time. This is the same tip as the one that we just looked at. This has just got some solder on it. I get years out of these tips. So very, very good tips. And I do that with all my irons. It's one of the little tricks to making the soldering iron tips last a long time. You see this has got a big ball of solder on it as well. And if we look at my desoldering tool, it's going to be the same as well. Look at that big ugly ball of solder hanging off there. So I know when I turn it on that it's going to be tinned, that there's actually going to be a piece of solder or a little bit of solder on the tip there, so I don't have to really think about it. I'm so diligent about this. I'm not kidding. Like I'll be working in the lab for hours and hours on end and, not getting any sleep like I normally do. Anyways, I'll go grab a coffee, right? Because that's the solution to no sleep, right? So I'll leave lab 1, go through lab number 2, and I'll get halfway through and I'll stop and I'll go, my irons are on. Have I added solder to the tips in a while? And I'll turn around and come back and check them, and I'll add solder to the tip, and then I'll go comfortably get my coffee. So I'm very diligent about that, and as long as you can keep that in your mind to always have, when the soldering iron is in the holder, make sure that it's not too hot, and again, always have some fresh solder sitting on that tip until you're ready to use it. And then when you're ready to use it, you have a sponge or whatever, clean it off and then use it, and then before it goes back in the holder, add solder to it and then put it back in the holder again, and you'll get an incredible amount of time out of your soldering iron tips. So anyways, there's some tips about tips, something like that. So there we go. So this one here is just as simple as you see it. A bunch of jumpers, resistors, some transistors, and that's it. Very, very simple. I haven't drilled these out to mount this onto anything yet, but I've just kind of pre-drilled them to, it was 0.026. You'll see that on the actual sheet. And there's a little bit of writing about that there. Now, if I grab a transistor of some sort, let's see this one here. Plug this one in. I can get these legs to plug in here. There we go. So you can see already we know that this is red is P, right? Red is positive, right? PNP. So we know that this is a PNP transistor. This is a 2N, right? 2N style transistor. So 2N3906, I imagine. There it is, 2N3906. So if I grab this one here and plug it in, you can see that these aren't evenly lit, and these ones are flashing back and forth, red and green. You can see it's going red, green, red, green, red, green. That means that this transistor is shorted, and it doesn't matter what socket you plug a shorted transistor into, it's going to find it. See that? So if we wanted to say take a Japanese transistor, so a C3242. So whenever you see a single letter like C, you put 2S in front of it. I've explained this in some of my earlier videos. For those of you that don't know this, this is the coding system. So if you see A733, you would know to put 2S in front of it. Or if you see C3242, you know it's 2SC. So they just don't put the 2S because I guess it just takes up too much room, right? Here's another little trick. A's and B's are PNP transistors. C's and D's are NPNs. So this is a C, so we know already that this is going to be an NPN. So if we want to test this, we got to use this socket here, which is for the 2SA to 2SD. And we want the transistor to face us, and then we're going to plug it in, and NPN. Now, there are some exceptions to this rule. I have some of those. I have one of those weird exceptions. You look at this transistor here, it's kind of an odd shape to it, and you'd think that this faces you, and then you plug this in, because it's A, right? It says A673, so we know that this is a PNP transistor already, because it's A, right? A's and B's, PNPs, C's and D's, NPNs, right? So we already know that this is a PNP transistor, so if I plug it in, facing me, you can see that one side isn't flashing, so that something isn't right here, right? So, and it looks like NP, nothing. So if we take this around, or turn it around the other way, so it looks like the back side is facing us, we get the correct reading, PNP. And it's because these transistors are like that. This has to face you. That's like the numbering is on that side. So for most 2SA, 2SC, 2SD, 2SB, whatever transistors, the base is on this side right here. On this transistor, it's on this side. That's why we have that. So you can know that just by turning it around. Remember, we're looking for evenly lit on each side and flashing the same color. We don't want it going between two different colors. Two different colors means there's an issue, right? So again, like if we put a faulty transistor in here, you can see it's two different colors, right? That's going red and green. It should only be flashing a single color going back and forth. So we know that there's an issue, right? So now, if we want to take a look at the other version, this one here, I really like this version with these LEDs. It's fast and it gives you that nice blue and red. So we know red is positive and blue is negative, so P and P, right? And we know that they're the same brightness level on each side. So we know that that is a definite good transistor. So if I plug a bad one in here, which I think it was this one here, we'll find out in a moment. Nope, that is a good one. So this is a PNP transistor. That's probably 2N3906 then. It is. That is not the bad one. Where is the bad one? Maybe this one? Let's see if this is the bad one. Nope. NPN. Where did the bad one go? The bad one is hiding on me. It is under here. No. Oh, this one here I think is the bad one. Okay, try this one here. You see how quickly I'm verifying transistors here. Bad. Nope, that's good. Now you can see this one's bad because this is glowing two colors at the same time, and it gives us that kind of a purpley, kind of violet, mauve, kind of bizarre color there. You can't see here because it really kind of, I guess you could say, overexposes on the camera. But you can see on the reflection on my fingers, that's that dual color there. And you can see this one here isn't lit very well, so we definitely know that this transistor is bad. No matter what socket you plug a bad transistor into, it's going to indicate it, right? So there's that dual color again. So this works very well. Now again, the nice thing about these is that they will solder directly to the same pads that the through-hole components are on. So nothing is different about this board. The only difference is the timing with this one. This is a little faster. And then we have the index line, which is the same for both, is facing this way. So you can see a little green line on these LEDs right here. That goes to the square. Okay. And this is all explained on the component layout map. And then you can see with this here, if I was to move this in here, you can see the flat side of this LED. I don't want to call it the cathode or anything like that, because there's really an LED each way in here. So the cathode this way and a cathode this way, so on each side. So I just prefer to call this an index on these LEDs. The flat side faces the square. It's very easy to remember on either one. Now you don't have to be worried about adding or taking a surface mount component and sliding it across here. Even if you run over these traces, it'll be fine. Just slide it on top and press down, and this will indicate whatever SOT23, whether it's a PNP or NPN transistor right here. Keep in mind that lots of different things hide in SOT23 package devices. But if you have NPN or PNP transistors you need to sort, like which I've been doing, I've been using this, you just slide them across and press down. So the layout itself is a really solid layout. It's just the lighting here that's making it look like that because of the tin or the actual plating on it. But you can see the layout turned out really, really nice. And it should for you too. If you follow my circuit board building videos, you'll get results just like this. It's very easy to make boards like this. This is actually really big traces for what I do. I make them hairline thin, and they work out really nice with the toner transfer method. See the little tantalum there. You'll see that as an addendum on the schematic, things like that. So there it is. So if you're enjoying these videos and the projects, you can let me know by tapping the heart symbol right below this video here on Patreon. And there'll be many more really neat projects coming. I have some really, really neat things happening here within the next couple of months. It's going to be there's going to be some, just like the low voltage capacitor tester and the Super Probe, I have some very, very neat things coming. My mind has been working overtime, and unfortunately, my sleep habits have not. So I'll have these things ready here very soon. I hope you're enjoying. I'll talk to you all very soon. Take care. Bye for now.